You've come to the realization that you need to increase your application performance, and after discussing it with your team, you think that maybe geolocation is the right solution for you. In this video, I'll show you how to implement geolocation. I'll help you understand before you get started if that's the right solution to your problem, and I'll teach you a little bit about the hidden costs associated with doing so. How's it going? I'm Will Button from DevOps for Developers, where I teach you how to build, scale, and grow your application using DevOps principles to build the DevOps skills that you need to succeed as a developer. So at some point, you're going to have to address application performance. And in talking over potential solutions, geolocation is going to come up. So geolocation is putting your application servers, your backend API servers, in multiple data centers in different geographic locations so that the servers responding to your users are geographically closer to the users themselves. It makes sense on the surface, right? Well, let's take a look at some real numbers to understand the exact impact that's going to have. If we're talking about across the US, East Coast to West Coast, or vice versa, network latency adds about 70 to 80 milliseconds to the overall latency. For traffic from the US to Europe, it's still under 100 milliseconds, and from the US across the Pacific Ocean, it adds just a little over 100 milliseconds. So let's look at a real-world example here from a client that hired me to implement geolocation for them. I've got their API response times here, and you can see their average response time, or their average latency, is about 1100 milliseconds, and the 95th percentile for their API is 5200 milliseconds. Most of their users were in the US, so using the numbers that we just learned about, we were going to take 70 to 80 milliseconds off of these numbers. And to be honest, if you take 70 to 80 milliseconds off of 5200 milliseconds, it's really pretty insignificant. No one's going to care about that, right? So that's the first rule of implementing geolocation is this really going to solve your problem? Is the network latency really the root cause of your application performance? And in this case, it's clearly not. Now, there are some applications where implementing some geolocation is going to help you. If you're dealing with really large assets like streaming video or streaming audio, putting those assets closer to the user is really going to help. But you don't need to implement geolocation yourself to do that. You can just use a CDN, or a content delivery network. To implement that, you just upload your assets to the CDN provider. They give you the URL to use, and you include that whenever you reference that media or that asset, and they take care of the rest. This also works well for front-end type applications where you can upload your CSS or your images and other static assets that you have and get those closer to the user while still keeping your back-end API in a single data center. So now those big assets that generally do take time to load are closer to the user, but your back-end API calls are still located in a single data center. And having everything in a single data center is actually a huge benefit. Let's take a look at some of the hidden costs of implementing georouting. So you know for a fact that you're going to be breaking your servers up into multiple geographic data centers, right? Now, if you have a lot of servers, like 50 servers and up, you can pretty much do the math and say if we're going into 2 data centers, we'll put half in each one, and it's going to work out okay for you. If you have a smaller application, though, with say like 10 servers, it's probably not going to work out like that. If half of your users are on the East Coast and half are on the West Coast, I've rarely seen it work out where you're able to put 5 servers in one location and 5 in the other. You usually end up with something closer to like 12 to 15 total servers, just to account for the overhead of the application running on your server, the CPU limitations, redundancy, fault tolerance. All of those kinds of things add up, and you end up having more servers than what you started off with in a single data center. Now, that's not the biggest obstacle to overcome, though. The biggest challenge you're going to have has to do with the data itself, right? Because your data, the source of data, can only be hosted in one location. And if you've got 2 data centers, you've got to figure out who owns your data, who's the authority for your data. There's a couple ways to approach this. One is to have a single database server in one of your data centers and then the API servers from the other location are going to have to make that network trip over to talk to that database. The other is through database sharding, where you identify some way of determining whether your users are going to be most likely to hit this data center or whether they're most likely to hit this data center, and then shard your database so that the data for those users reside in the same data center that they're most likely to hit. That's actually really, really complicated and really hard to get right. Unfortunately, the penalty for getting it wrong is really steep because undoing a sharded database is just a nightmare. So you've got to really understand what your user behavior patterns are and make sure that you're highly, highly confident that you've gotten it right before you implement that. There's also another aspect of this too. Now that we've got multiple data centers, there's going to be some amount of traffic between the data centers. For example, the database replication, keeping the databases in sync with each other. Now, all of that has to happen over a secure tunnel through like a VPN or VPC networking if you're using AWS. So someone is going to have to set that up and maintain that, and then make sure that that stays in a secure configuration as well. So all of those things add up to extra overhead above and beyond just pushing your code out to multiple servers that are geographically isolated from each other, and then using a GeoDNS entry to identify the correct data center for a particular user. So if we recap all of this, first thing we need to do is make sure that geographic latency is the real problem or the root cause of our problem, and understand that we're only going to be saving about 100 milliseconds in a best case scenario by geographically locating our services. We also want to understand that by doing this or implementing this, we're adding a lot of overhead to our infrastructure as well in terms of networking, security, the sheer number of servers that we have to support, and secure communications between the data centers. And the final piece is we can still gain a lot of geographic benefits just by using a CDN provider to host our large and our static assets like audio, video, CSS, and images used by our front-end application, and get a lot of the benefits of geographic location without the actual implementation of putting our API services into geographic data centers. So now this customer that I referenced in the beginning of the video, what we ended up doing there was digging into the application performance, finding some poorly formed or poorly performing SQL queries that were causing that high latency on their API, and correcting those. So the end result is they actually paid me a lot of money to not implement the thing that they hired me to implement. And that actually takes us right into the next topic I'm going to record. And that's why I don't like JavaScript or Node.js for a backend service. So I'm going to stop this video here, go record that one, and if you want to get notified when I release it, be sure and hit the subscribe button down below. I'll see you in the next video.